In PROM, user can design the instructions only once. He cannot change the instructions later when required. The major disadvantage of PROM is that a shock of electricity can easily cause fuses in ROM to burn out, thereby corrupting the PROM. EEPROM, erasable programmable read-only memory. Although PROM is not a flexible memory, as the instructions in it cannot be changed. EEPROM is designed to overcome the drawback of PROM. In a black circle in EEPROM, the user can program the instructions himself according to his requirement and can also erase the instructions later by using ultraviolet radiation, UVR. EEPROM, electrically erasable programmable read-only memory. It is also the read-only memory, and user can reprogram the instructions according to his requirement, but here the instructions will be reprogrammed through special electrical pulses. EEPROM such as flash memory allow the entire ROM to be electrically erased then written to without taking them out of the computer. In EEPROM, user can electrically erase a portion of the contents of the row. This is very important in situations where minor changes to the ROM content are needed. Cache memory. The processor accesses the main memory to read the instructions. The speed which the processor executes the instructions is much faster than the speed at which the instructions are transferred from the main memory. In order to make it compatible, a small very high-speed memory is used between main memory, RAM, and processor. This type of memory is called cache memory, buffers. Features of cache memory are: cache memory is small, fast and expensive type of storage that is placed between the CPU and the main memory. The CPU transfers the instructions from the cache memory towards its processing area at the very high speed, thus it improves the processing speed. Hence, instead of every memory time reading from the main memory, now CPU first check the cache memory for the required data, and if the CPU finds the data there, it is called cache hit, and if the required data is not present in cache, CPU then reads it from main memory. This state is called cache miss. The advantage of cache memory is that the CPU does not processor have to use the motherboard's system bus for data transfer. CPU, whenever data must be passed through the system bus, the data transfer speed slows to the motherboard's capability. The CPU can process data much faster by avoiding the bottleneck created by the system bus. Cache memory is random access memory, RAM, that a computer microprocessor can access more quickly than it can access regular RAM. As the microprocessor processes data, it looks first in the cache memory, and if it finds the data, it does not have to do the more time-consuming reading of data from larger memory. Initially, the cache memory is empty. When CPU accesses data from main memory, it places a copy of it in cache memory. This process continues for each access to main memory. When cache memory becomes full, then the new data will be stored by replacing some existing information using a FIFO, first in first out, algorithm. Cache memory is not addressable by the user of the computer system. Its purpose is to look ahead and to provide the CPU with currently needed information. Cache memory makes main memory appear to be faster and larger than it really. It is very expensive as compared to the main memory, and hence its size is normally very small. Today, cache memory is embedded with the processor of the system, and normally processor provides up to 4 megabytes of cache memory, but we can also upgrade the cache memory of the system by introducing external cache memory. Virtual memory. When the computer is to process a large amount of data, sometimes the size of main memory or RAM becomes inadequate or not sufficient to store the data. To overcome this problem, the technique of virtual memory is used. In this case, operating system approaches to the secondary storage, hard disk, and borrows the required amount of memory from it and utilizes it as a main memory or RAM for processing the data. This borrowed or shared memory is called virtual memory. When virtual memory is being used, the system allows the users to carry on working without worrying about the availability of data storage or memory saturation. It is often addressed as logical memory and allows users to access a larger volume of memory and access different applications simultaneously. RAM versus ROM. RAM. Information retrieved anytime. Volatile storage. Stored. It is read, write memory. Information can be altered. ROM. And black circle information is permanently stored. It is possible to randomly select and store the information. Execution speed depends upon the capacity of RAM. RAM allows the computer to read data quickly to run applications. Non-volatile storage. It is read-only memory. Information cannot be altered. It is not possible to randomly select and store the information. No such dependency. ROM stores the program required to initially boot the computer. The two main types of RAM are. The types of ROM include PROM, static, secondary memory, EPROM. This type of memory is also known as external memory or non-volatile. It is slower than the main memory. These are used for storing data, information permanently. CPU directly does not access these memories, instead they are accessed via input-output routines. The contents of secondary memories are first transferred to the main memory, and then the CPU can access it. For example, disk, CD-ROM, DVD, etc. Characteristics of secondary memory. These are magnetic and optical memories. It is known as the backup memory. It is a non-volatile memory. Data is permanently stored even if power is switched off. It is used for storage of data in a computer. Computer may run without the secondary memory. Slower than primary memories. The various types of secondary storages are magnetic storage, optical storage, solid-state storage.